According to the question, this point F here is a variable point, and as it moves, it is going to trace out a curve. Our aim is to find the equation of this curve. So to do that, let's first try to find the equation of the line that passes through D and E, which is also the tangent to the curve C at the point P. So let's try to find dy dx for the curve C. Dy dx for the curve C, which is in the parametric form. First, let us try to find dx dt. Differentiating this will give us a minus 3 over t squared. And I want to differentiate y with respect to t also. So differentiating this with respect to t, it is going to give me a 2. So with this, I can now find dy dx, which is dy dt divided by dx dt. Dy dt is 2 divided by dx dt is negative 3 over t squared. This will give me a negative 2 over 3 of t squared. And with this, let us try to work on the equation of the tangent at P. So at the point P, from observation, since this xy coordinate is also a point that is going to be on this curve, so from observation I can see that T is going to be equal to P. T is going to be equal to P. So at this point here, the parameter T is going to be equal to P. The x coordinate is going to be 3 over P. And the y coordinate is going to be 2p. And how about the gradient? Dy dx for the curve is in terms of t, and t is equal to p. So dy dx is going to be equal to minus 2 over 3 of p squared. With this set of information, we can then find the equation of the tangent. So equation of the tangent at the point P will be y minus the y coordinate is equal to the gradient minus 2 over 3p squared of x minus the x coordinates, which is 3 over p. Let's now try to find the coordinates of D and E. So at the point D, the y coordinates is 0. So I'm going to let y be equal to 0 here. So at point D, we will have a 0 minus 2p is minus 2 over 3p squared of x minus 3 over p. From here, we can work out the value of x. The value of x is going to be equal to 6 over p. This tells me that the coordinates of D will be 6 over p, 0. Let's do likewise for the point E. The point E lies on the y-axis, so the x-coordinate is going to be equal to 0. So letting x be equal to 0, it will be y minus 2p is minus 2 over 3p squared of 0 minus 3 over p. So with this, we can find the y-coordinate of E, and that will be 4p. So I know the coordinates of E is going to be 0 and 4p. This will help us to find the coordinates of F, because according to the question, F is the midpoint of D and E. So using once again coordinate geometry from our secondary school, it will be x1 plus x2 divided by 2, then y1 plus y2 divided by 2. So it will be 6 over p plus 0 divided by 2, and the y coordinates will be 0 plus 4p divided by 2. This gives me the coordinates of F to be 3 over p and 2p. And since p varies, that means what we are seeing here is yet another parametric equation. Another parametric equation with the x as 3 over p and the y is 2p, where p becomes the new parameter since the question says that p varies. So what we want to do is looking at this as a new pair of parametric equation, we want to find the Cartesian equation of this pair of parametric equation, because the Cartesian equation of that will give us the Cartesian equation of this curve C, of this curve that F is trying to trace. So what we will do is, how about taking this multiplied by this, x multiplied by y. So x multiplied by y will be xy, and this multiplied by this will be 3 over p multiplied by 2p. So my answer for the curve that F will trace out is going to be xy is equal to 6.